Okay, we're going to look at some problems that will help us review from some of our Section 5 sections that we've done. So the first thing we'll look at is we're trying to find the trig values of a triangle. So this first one says, given the tangent of theta equals 5, 6, find the value of the other 5 trigonometric function values. So if we write all 6, we know sine theta is one we're looking for, cosine theta. Tangent theta is one we're already given, it's 5 over 6. Then remember we have our 3 reciprocal ones. We have cosecant, we have secant, and cotangent. So these are the ratios we're trying to find in this problem. So the easiest way to do this right now is to just set up a triangle, a right triangle of any sort, and then we're going to put a 90-degree angle in it, and then somewhere we're going to put a theta. We're going to put a theta in some corner, it doesn't really matter. And the only reason we need the theta is to really define what our hypotenuse is, what our opposite, and what our adjacent is. So this is the hypotenuse side, and this would be the opposite side, and this would be the adjacent side. Now all we have to do is figure out how we can get numbers for these, and then just solve the problem. So if you remember SOHCAHTOA, it tells us what sides are related for each ratio, and in this one we're dealing with tangent. So tangent is 5 over 6, so the opposite is 5 and the adjacent is 6. So this is 5 and this is 6. So now all we have to do is find the hypotenuse, which we can do with Pythagorean theorem. Because this does work for right triangles. It doesn't work for non-right triangles, but it does work for right triangles. So c squared equals 6 squared plus 5 squared, because we're missing the hypotenuse. So c squared is 61. So c is square root 61. So now we have all the sides, so we can just start finding our ratios. So sine is opposite over hypotenuse, so that's 5 over radical 61. And then like we talked about, we can rationalize that, make that 5 radical 61 over 61. Cosine is the adjacent over hypotenuse, so that's 6 over radical 61, which is 6 radical 61 over 61. And then our other 3, remember, are just the reciprocals. They're just the flips. So if I flip 5 over radical 61, I get radical 61 over 5. Same thing for cosine. I'll get radical 61 over 6. And for cotangent, I'll get 6 over 5. So really important to remember which functions are co-functions, reciprocal functions, which was other ones in these ratios. All right, the second problem is kind of a problem where you're trying to find a missing side in a word problem application. But again, it's something that deals with triangles and solving triangles, which we did a lot in section 4 and 5 using law of sine, law of cosines. You could also use trig ratios if it's a right triangle, but law of sine and cosine is a pretty easy way to go. So we have a building in this problem. So here's my floor. And it says the angle of elevation to the top of the building is 80 degrees. So if I look at the top of this building, we get an 80-degree angle. Since it's a building, we'll hope it's at a 90-degree angle. So for our triangle here, we have a right triangle. And it says we know the building is 200 feet tall. So that building is 200 feet tall. And the goal is to figure out how far away from the building do you have to be standing to get an 80-degree angle to the top. So we'll call this x. Now, lots of ways you can do this. You can do law of sine. You can do just a trig ratio. I'm going to do law of sine. So I know this angle is 10. And so I could do the sine of 10 degrees over x equals the sine of 80 over 200. And then just like before, we can cross multiply and solve for x. So we get 200 sine 10 equals x sine 80. And so I'll divide both sides by sine 80. And now everything on the left side is simply going to be a number. And that number is going to turn out to be 35.3 feet. So to have an 80-degree angle, you need to be standing 35.3 feet away of a 200-foot building. Now, big thing to remember, make sure your calculator is in degree mode. whether that be on Desmos, on your handheld device. Somehow you have to have your calculator in degrees or it will not give you the correct answer. Now, question 3 is kind of an interesting question that we really haven't done specifically, but it takes us back to a couple of things we did before the sections on triangles with the radian measure and with the 30, 60, 90 triangles. So this says, find the exact value of cosine 60. Well, we know cosine is adjacent over hypotenuse, but we really don't have a triangle. But the good news is we do know 3 angles really well. We know 30, 45, and 60. From our triangles from before. If I have a 30, 60, 90 triangle, if you recall the ratios of those sides, we have the side across from 30 is 1, the hypotenuse is double that, and the other side is root 3. So if I want to answer a question about 60, well then I know this is the hypotenuse, this is the opposite of 60, and this is the adjacent of 60. So now for adjacent over hypotenuse, I know the cosine of 60 is 1 over 2. And that's just my answer is 1/2. Now the big thing I want to point out to you is this word exact. You cannot give me a decimal answer for this. You actually have to give me something that's either a nice fraction or a square root. Something has to be in an exact form, not a rounded decimal. Now the second problem in this says the sine of pi over 4. Now sine of pi over 4 is in radians. So we'll first have to change this to degrees. So if you remember how to change from radians to degrees, we multiply by 180 over pi. We did this in section 1. So the pi's will cancel out, so we get 180 divided by 4, which is 45 degrees. So finding the sine of pi over 4 is the same as finding the sine of 45 degrees. And again, this would be impossible if we did not have that special triangle we knew from the last chapter. So there's a 90, there's a 45, there's a 45, and remember the legs were the same, and the hypotenuse was square root of 2 bigger. So we're dealing with a 45, it doesn't really matter which one, I'll say it's this one. So that makes this the hypotenuse, this the opposite, and this the adjacent. You'll notice the opposite and adjacent are the same in this case. So our solution to the sine 45, sine is opposite over hypotenuse, so it's going to be 1 over the square root of 2, which if I rationalize is simply square root of 2 over 2. So now let's just look at solving some triangles. So just remember, when we solved triangles, we had 2 laws we really were solving these with. We had the law of sines, which was when we had ASA, AAS, or SSA. And remember the SSA case is where you have to look if there is a second triangle or if there's no triangles. Then we had the law of cosines, which we used when we had 2 sides and the angle in between versus the non-included angle, or if we had all 3 sides. So I make sure you know those laws, have those formulas down so you can apply them to these triangles. So if we look at this first triangle, this one's kind of an interesting one because we have all 3 sides, but we also have an angle. So we have SAS, we also have SSS, we also have SSA. So I'm going to use law of cosine since it has all 3 sides. And law of cosines can be used to find angles or sides. So I'm just going to find, without loss of generality, I think I'm going to find angle B. Now that matters because remember in our law of cosines, when you pick the formula, whatever angle you're finding or whatever angle you're giving, that side has to go by itself. So this would be b squared equals a squared minus 2ac cosine big B. And so now we'll plug those values in. So we get 5 squared equals a squared, which is 15 squared, plus c squared, which is 13 squared, minus 2 times 13 times 15 cosine B. And so our goal is just going to be to solve for cosine B. So we know 5 squared is 25, and then we do this in chunks. We'll do the 5 squared plus 13 squared. So 15 squared is 225, and 13 squared is 169, so that's 394. And then we'll just do the next chunk, which is the 2 times 13 times 15. So 2 times 13 times 15 is negative 784 cosine B. Then importantly, I don't want to put those together, but I'll subtract the 394 from both sides. So 25 minus 394 is negative 369 equals negative 784 cosine B. I'll divide both sides by negative 784. So I get the cosine of angle B is equal to 369 over 784. Now remember, when you're finding an angle, we have to use those inverse trig functions. So I'm going to be taking the inverse cosine of 369 over 784. So what I get is I get 61.9 for my angle. But right away I see a problem. So 61.9 degrees. Now remember what we said. We said the biggest angle has to be across from the shortest side. Well, 5 is the shortest side, but that is 61.9 is not the smallest angle. So that is a problem. So because the smallest side is not across from the biggest or smallest angle, this is not a triangle. These are not dimensions that would make a triangle in this case. Let's look at number 5. Number 5 is a triangle that has an angle, a side. So this is side-side angle. So side-side angle is law of sines, but it's the one that may have a second solution. So when I'm solving this, sine of A over A equals sine of B over B. So when I'm solving it, multiply both sides by 20. We'll get sine B equals 20 sine 30 all over 15. And we'll take the inverse sine to find our solution of B. Now this could give us no solution, this could give us an answer, and if it gives us one answer, we have to check if there is another answer that could also work. So when I do the inverse sine of 20 sine 30, 15, obviously being in degrees, I get 41.8. So we have a solution. We have at least one solution. So B could be 41.28. Now, the way to check for a second one, we'll call it B1, is let's take 180 minus 41.8, and I'll get 138.2. So if I look at B, I could definitely put 41.8 in there, because 41.8 plus the existing 30-degree angle is less than 180. But I could also, if I draw the same triangle down here, I could put 138.2 here, because 138.2 plus the existing 30 is also less than 180. So we're actually going to have two triangular solutions. We're going to have two answers for this. So now what we have to do is now we have to go and we have to find the third angle for both. Now the third angle, relatively simple. All you have to do is 180 minus the two existing angles. So this one's going to turn out to be 108.2, and this one's going to turn out to be 11.8. But now we have to also find the C's for both of them. So I'll look at the top one first. So I want to find C, so I'll do sine 108.2 over C equals sine of 30 over 15. Cross multiply and work it out like we've done. You get 15 sine 108.2, and then we'll divide that by sine of 30. So side C is going to be 28.5. Now that's the C for this first triangle. So now this triangle is completely done. We have all three sides and all three angles. But because we had a second possibility for the bottom, we have to find its C2. But it's essentially the same thing. Sine of 11.8 over C equals sine of 30 over 15. I'll let you work that one out, but I get a C of 6.1. So the key is to always check when you have side-side angle and you get a solution, check if there's a second. Do 180 minus the first, see if you have a second solution. All right, so if you look at this problem 6, this is a pretty straightforward side. So this one's going to definitely be law of cosine. So we'll do it very similar to what we did on the previous problem a couple problems ago. So I'm going to pick an angle to solve for. I'll solve for angle B first. Doesn't really matter, but this is going to be law of cosine. So if I want angle B, when I write my formula, I want it to start with B. So little b squared equals a squared plus c squared minus 2ac cosine B. So here's little b, here's little a, here's little c. So little b is 3, so this is 3 squared equals 8 squared plus 9 squared minus 2 times 8 times 9 cosine B. And again, work it in chunks. Do this part, and this part independently. So 3 squared is 9. 8 squared plus 9 squared is 145. Negative 2 times 8 times 9 is negative 144 cosine B. Then I'll subtract 145. So 9 minus 145 is negative 136 equals negative 144 cosine B. I'll divide both sides by negative 144. So cosine B equals 136 over 144, which I'll take the inverse of. So B is going to equal the inverse cosine of 136 over 144. So I get 19.2 degrees for B. So now I have to do the same thing one more time to find either A and C, and then I can do 180 minus. So we'll set up finding A, and then I'll let you do it. We won't put all the work here. But we'll start with A. So A squared equals B squared plus C squared minus 2BC cosine A. So A squared is 9 squared equals 3 squared plus 8 squared minus 2 times 3 times 8 cosine A. So go ahead and work it out like we did the previous one. A should work out to be 99.6 degrees. And then we'll do 180 minus the two existing angles. So angle C will turn out to be 61.2 degrees. So make sure you get those same answers on your paper as I got here. All right, let's look at this last problem. It says points A and C are on opposite sides of the Grand Canyon. So I'll put 2 points on the opposite sides of some segment. And point C is 200 yards from angle A, or from point A to 200 yards. And angle B measures 87. So you can see we have a triangle now. And angle C measures 67. And we want to know how far it is between A and B. So what you have here is you see you have two angles given and a side. So this is just simply law of sines. This is just a word problem that deals with that. So we have sine of 87 over 200 equals sine of 67 over x. And so again, it's just really setting up a triangle and solving. Nothing too crazy about it. So x sine 87 equals 200 sine 67. And I'll divide both sides by sine 87. So 200 sine 67 over sine of 87. And I just put this in the calculator and I come up with 184.4, and this would be in yards because this is a word problem, so we need to make sure we put our unit. So just a quick reviewing some of the problems we did in this chapter. If you have questions, obviously bring those questions to class and we can talk about them there.